All right, let's talk about this bulwark. So, absolute value is technically a function. It always does something to the expression that's on the inside. If you look at the expression that's on the inside of an absolute value, you simplify it, you evaluate it, and it is a negative value. What does the absolute value do to it? Makes it positive. How can we do that with a different operation? Yeah, we'll multiply what's inside by negative 1, because that would have the same effect of changing the sign to a positive, correct? If the expression on the inside of the absolute value is already a positive number, will the absolute value change it? No. So give me a mathematical operation that we can do that will not change the value of anything. Multiply by positive 1. Multiplying by positive 1 would have no effect on it, correct? So the absolute value will either be multiplying it by a positive 1 or a negative 1, depending on what's going on inside. So let's look at these. If x is a number that is less than 4, how would the inside evaluate? Positive or negative? Negative. Absolute value is going to change that into a positive. So we would have negative 1 multiplied by what's on the inside there. And so this would simplify to be what? Negative x plus 6. Or how else could you write that would be equivalent? 6 minus x. Number 2, if x is a value that is less than negative 3, what would this expression be, positive or negative? Negative. Just the part on the inside would be a negative. Absolute value is going to change that. So how do I write it down without the absolute value? Negative x. What about if that had said x is greater than 2? Would the absolute value change it at all? So that would be the same as what? Times 1. So I would just have x. It would remain unchanged. I would just disregard the absolute value bars because they're not going to affect it at all. Number 3, if x is a value greater than 1, what type of number would the inside evaluate to? A positive. Will the absolute value change anything about a positive number? No. So how can I write this without the absolute value anymore then? Just x plus 2. Or 2 plus x, absolutely. There was a problem on the homework that was similar to number 3. I got a deluge of emails over the last 2-3 days. I was being stopped in the halls. Totally understand. It felt like a trick question. Because all the other ones that we'd mainly focused on in practice was when we had to do something different to it, when we had to multiply it by negative 1. But if it's already a positive, recopy what's on the inside, and you're finished. Sound fair? Cool. All right, we're going to finish up our 1.2 notes today. When is your 1.2 homework due? Monday. 1.2 homework is due on Monday. All right.
Wait, Monday at 11:59, right?
Yes.
So it's basically due Tuesday.
I mean,
Monday night.
I've gone back and forth because I've had things due Tuesday morning before, but then I'll have people come in, they're like, I always look on my Canvas calendar for when I need to do stuff, and if it doesn't show up until Tuesday, they don't check the times. So, yes, you have all day Monday to get it in. Please make sure that you are working on that over the weekend so that if you run into problems or questions about how to type something in Canvas or what does a question mean, you've got Monday class time to ask me about that before it's actually due. All right? All right, this is where we left off yesterday, correct? We were just getting ready to start talking about rational exponents. When I'm talking about numbers, what does this word rational mean? Fractions. We've got some fractional exponents here. So if I have the nth root of a, that is the same thing as a to the 1 over n power. I don't like that particular type font because 1 over n doesn't really look like an exponent there. If I have an nth root of a to the m power, that is equivalent to the nth root of a whole thing taken to the mth power. When I write this as a rational exponent, my index goes down on the bottom of my fraction, and my power is my numerator. Let's try this one down at the bottom. I have the cubed root of x squared. Give me an equivalent way that I could write that using rational exponents. X to the 2/3. Absolutely correct. I'm curious on an equivalent way that I could write this, but that uses roots. Can you give me another way that I could write this that still uses a radical? Yes, absolutely correct. That would be equivalent. All right, let's do some practice with these. We'll start off with some easy ones. How can I rewrite the 5th root of x squared using rational exponents? We'll start with, what's my base? X. What is my index? 5. Where does that belong in my rational exponent? Bottom. And then what would my numerator be? 2. Before we go on to the next example, I want to talk a little bit about if this was not the problem but the answer, how would you type something like that into Canvas? So let's talk about how to take things like this and put it into Canvas. So if I had a square root, let's say just like square root of y, the way we would type this into Canvas is SQRT for square root, and then inside parentheses, I'm going to put whatever is under that radical. For something like the 5th root of x squared, I can't write square root because it's not a square root. So I'm still going to keep the abbreviation for root, but I'm going to type out 5th since it is a 5th root. So FIFTHRT. And then what is it that we are taking the 5th root of? X squared. How do I write x squared in Canvas? X caret 2. All right. So again, that's if I need to type in radicals and roots into Canvas. You guys won't have to do this very often in Canvas. The most common one that shows up after this unit is square roots, SQRT. But for this assignment, we have fifth roots and cubed roots and fourth roots, and so we need to have some consistent way of typing that in. If anybody has opened up the 1.2 homework, I'm not sure if you have or not, but the directions there have a little table like, if your answer is this, type it in like this as reminders for that. Anything that you're not sure how to input, please send me a message. If there's minor differences between the way you typed it in and the way I would have typed it in, but the way you wrote it is mathematically correct, I always go back in and check those things and give you guys full credit for things that are equivalent. Okay? All right, part B. What is my base on B? Remember, I want to write this with rational exponents. X plus y is my base. Do I need parentheses around that? Yes. And then what would my rational exponent be? 3/4. Last one on here, part C. Tell me an equivalent way to write this using rational exponents. Start with my base. A squared plus 16. Do I need parentheses? Yes. To the power of what? To the power of 2? 1/2. 2 would be my index, so my denominator. 1/2 power. Quick note, and this is similar to what had shown up on that common mistakes page from the first day. The square root of a squared plus 16 is not equivalent to a plus 4. Why? Yes. So if I were to take a plus 4 and square it, what do I get? A squared plus 8x plus 16, which is not a squared plus 16. So far, so good on that one? Okay. I want to take these guys and write them as radicals. They have rational exponents. I want to write them as radicals. On the first one, part A, what is being affected by the exponent? The x. Is the 3 being affected by the exponent? The 3 is not being affected by the exponent. What would it have to look like if the exponent, that 2/5, was also being applied to the 3? There would have to be parentheses around it. As it is currently written, 3 is being multiplied to x to the 2/5 power. So thinking about my order of operations, only that x is being affected by the exponent. Multiplying by 3 would come later. So as I rewrite this, the 3 will not go underneath the radical at all. So I'm going to have 3 times, what is my index here? 5, so 5th root of what? X squared. Yes.
So you wouldn't need parentheses around the x?
Like this guy here?
No, like,
Around this?
yeah, and you wouldn't put like the square outside of it.
That, I actually was just, that's what my or was leading into. You got it. It's like I planted you in the audience. So the question was, wouldn't you or couldn't you write it like this? And the answer is absolutely yes, you can. That is an equivalent way of writing x to the 2/5 power. You can have that 2 underneath the radical or outside the radical. It does not matter. On part B, what is being affected by the rational exponent?
X minus 4.
on part B?
Or, no, I'm sorry, I was doing C in my head. On part B, A.
A is being affected by my rational exponent. Anything else? The 2 is also being affected. So the 2 is going to have to go under our radical. So give me one way we could write this. What's my index on my root? 4. What's it look like after that? 2a. Where should I put the parentheses? Around this or around this?
2a.
Around 2a, okay. And then do what?
Put the, make that to the third power.
Make that to the third power. I can think of an equivalent way of writing this. I'm still going to have a 4th root. I still need 2a under it. Put the power of 3 outside of this whole thing. Those are equivalent. Absolutely the same thing. All right, and the last one, part C. What is my base that's going to go underneath the radical? X minus 4. Are you feeling okay? Okay. What's my index? 5. Done. I want to draw one thing to your attention here. The 5th root of x minus 4 is not the same as x to the 1/5 minus 4 to the 1/5. Remember, we cannot apply exponents to two parts of a sum or a difference. We can with a product or a quotient. So if it has multiplication or division, we can kind of distribute that exponent, but not with addition and subtraction. Do you guys have any questions for me so far? Cool. We're going to switch gears for a second. We're going to learn one new thing. Now, this is brand new. This is not something that I would expect you to know from Algebra 2. However, it relies on skills that you've learned in Algebra 2. We're going to do something called rationalizing the denominator. When you rationalize the denominator, what that means is no roots in the denominator. This is actually something that shows up quite a bit. I want to rewrite these fractions so that they have the exact same value, but so that they don't have radicals in their denominators any longer. So I'm going to start off with the top 3 examples. If I want to get rid of the square root of 7 that's down in that first denominator, what could I do? Square it? Let's check. I'm going to try it with some numbers, whole numbers that I can do in my head. If I took something like 1/2 and I squared it, do I get something that is equivalent to 1/2 as a result? No. So I can't square it. It'd be great if I could. Yes, sir. We can multiply top and bottom by our denominator. Radical 7 over radical 7. Because radical 7 over radical 7 is the same as what? 1. So I'm multiplying my fraction by 1. If I multiply by 1, will it change the value? No. So that is 100% valid if I want something equivalent. How do I multiply fractions? Straight across, top to top, bottom to bottom. So in my numerator, I now have a radical 7. What would I have in the denominator then? 7. I still have a radical in my expression, but it is no longer in the denominator, which is what I was asked to do. Before I look at any of these other examples, what questions do we have here? look at the next one. How do I rationalize this denominator? I'm going to multiply by what? Radical 7 over radical 7. I know that means my denominator is going to come out to be 7. What's in my numerator? I'm going to have square root of 5 times 7, because they have the same index on the roots, so I can multiply those values together. Which is going to simplify to what? 35. So radical 35 over 7. This third one over here. I can think of 2 different ways to go about this problem and end up with the correct answer. One of them is much easier than the other. Yes, sir. Yes. The question was, can't we just divide them? Radical 35, well, this is radical 7 times 5, which is the same thing as radical 7 times radical 5 over radical 7. And then I can cancel these 2 out, because radical 7 divided by radical 7 is 1, which means my simplified answer would be what? Radical 5, and I have rationalized my denominator because I don't have any radicals on the bottom of the fraction. The other way that I could think to do this would have required simplifying the radical. It would take a lot more steps. You'd get the same final answer. Remember, your answers have to be fully simplified. Since we didn't go that route on this problem, I do want to revisit simplifying a radical very, very quickly, just to make sure we remember how to do that. If I have square root of 12, can that simplify? Yes, I can write 12 as the product of at least one perfect square, correct? 12 is the product of what and what if I want one of them to be a perfect square? 3 and 4. And so that would be the same thing as the square root of 4 times the square root of 3. Square root of 4 is a perfect square. It simplifies to what?
2.
So 2 radical 3. This is the process that you would have had to go through if you had just multiplied top and bottom by radical 7. You would have to simplify the radical in the numerator, and you would see that those 7s would cancel. And it would still leave you with radical 5 as your final answer. All right. So those are the ones up on the top when I have a single radical in my denominator. What about if I have a sum or a difference where one piece is a radical? How do I rationalize the denominator?
Wouldn't you still just focus on the radical?
Let's try it. If I multiply top and bottom by radical 7, that means I need to distribute, right? I'm still going to have a radical in the denominator. It switched spots, but I still have a radical in my denominator.
Yeah, would you multiply by the entire denominator?
So close, it's not even funny. So I want to think about polynomials. I want you to think to algebra 2. I want a quadratic that has only an A term and a C term, that has no B term. So something like A squared minus 16.
Oh.
Square.
Difference of perfect squares, because how does that factor?
Those are so easy. It goes A plus or minus 4.
Yep, A minus 4, A plus 4. When I multiply those two together, I have no term that just has A. I have something squared and something else squared. That's really helpful when I'm trying to get rid of a square root, right? These guys right here have a special name. I heard you guys say the name for this already, difference of perfect squares. When we have it in its factored form, we call these conjugate pairs. Will I ever test you over it? No. Will I ever use that phrase again? Yes. Because it actually shows up in a lot of different circumstances. We have other things that mimic the behavior of a difference of perfect squares, and I want to be able to work with it in ways that I don't have that B term, and so I'll say, oh, well, what's the conjugate pair for this? And when I'm thinking about conjugate pairs, what's the difference between those two factors? One's a negative, one's a positive. So anything I can look at and immediately come up with its conjugate pair just by changing the sign. Does that make sense? Okay. So I want to apply that to this problem here. What would the conjugate pair be for 1 minus radical 7? 1 plus radical 7. If I only multiply the denominator by that, is that valid? Will I get something that is equivalent? No. I have to multiply by 1. So I need to multiply my numerator by the same thing. So far, so good? In my numerator, I've got 2 times 1 plus radical 7. Down in the denominator, I'm going to need to distribute this. I'm going to show the distribution this time. But then when we get to some other problems, I'm going to drop the whole process. You're welcome to continue doing it on yours, but I'm going to have 1 times 1, 1 times a positive radical 7, negative radical 7 times 1, negative radical 7 times positive radical 7, which means minus 7. What's going to simplify down here that makes me really happy? The radicals totally disappear, and now I have no radicals in my denominator anymore. Will that denominator simplify further than that? Can I do anything with the whole numbers that I've got? 1 minus 7, which gives me negative 6. We normally don't leave negatives in our denominator. If you write the denominator with a negative, I'm not counting it wrong. But standard mathematical notation has my negative either out in front of the fraction or distributed into my numerator. Your numerator, you can distribute that if you like, or you can leave it as is. So you could write this as 2 times the sum of 1 plus radical 7, or you could write 2 plus 2 radical 7. I do not care. You don't have to distribute on these fractions for me to count it as fully simplified. Oftentimes, if you leave fractions in their factored forms, I can see that you have checked to make sure that everything reduces. Let's do one more like that. What is the conjugate pair for the denominator in this last one here? 2 minus square root of 6. So top and bottom, 2 minus square root of 6. In my denominator, I know that means that I'm going to have what after my b term cancels out? 4 and 6, with what in between them always? Radicals are going to cancel, but what operator in between? Negative, minus. Because remember, this is basically coming out to be a difference of perfect squares. So when I multiply by the conjugate, square the first minus square the last. All right, let's distribute this numerator out. I've got 4 times 2, which is 8. 4 times negative radical 6, so minus 4 radical 6. Shrink this just a bit. And then I have to distribute my negative radical 3. So I end up with minus 2 radical 3. And then how do I multiply a negative radical 3 with a negative radical 6? I get a positive. Radical 18, yes. Because they're under the same type of radical. The radicals have the same index. They're both square roots. I can multiply those pieces together. Can I simplify anything in the numerator? Yes. What can I simplify? There's only one piece. Radical 18. We know that 18 is the product of what and what? 9 and 2. So radical 18 is going to simplify to what? 3 radical 2. So I'm going to rewrite that numerator as 8 minus 4 radical 6 minus 2 radical 3 plus 3 radical 2. Can I combine any of those pieces? No. When I'm talking about addition and subtraction, I have to have the same value under the radical in order to be able to add and subtract things together. Will my denominator simplify at all? Yes. What will it give me? Negative 2. So I'm going to bring my negative out to the front and put the 2 on the bottom. How we doing?
Good.
Good. I'm going to practice the same skill. This does not come up as often, but every now and then you would be asked to rationalize the numerator. So I'm going to throw it on here. Same exact process as rationalizing the denominator. Most of the time, we're only worried about rationalizing the denominator. And I will tell you, from today until the end of school in May, if you get a radical in your denominator as part of your final answer, it is expected in pre-calculus that you rationalize it before it would be considered fully simplified. So that skill we're going to practice over and over. Let's rationalize our numerator here. What would I multiply this top fraction by to rationalize the numerator? 1 plus square root of 6. So what will that give me up in the numerator after I distribute? What will I have in the numerator after I distribute? We're not going to have a radical anymore. Remember, that's why we're multiplying by the conjugate pairs, so that we don't have a radical anymore. Oh, I see what you're saying. You were distributing the whole thing out. Okay, got it. So 1, and then you said plus 1 radical 6. Negative radical 6. Negative radical 36. I see. Got it. All over 2 times 1 plus radical 6. These guys are going to cancel, and I know that this simplifies, right? Square root of 36 is what? 6. This is where I thought you were going, and this is why I was a little bit confused. So I've got 1 minus 6 in my numerator, basically. Did you have a question? Okay, sorry, I saw your hand go up a little bit. I wasn't sure if I was missing something here. Over 2 times 1 plus radical 6. Can I simplify that at all? Yes. How would that simplify?
Numerator and denominator, or just the denominator?
Definitely need to simplify the numerator.
So that would be -5, and then the denominator would be 2 plus 2 square root of 6.
Yep, you can write that as it looks right here, or you could write 2 plus 2 radical 6. I don't care which way you leave that. When you're fully simplifying things, when it comes to fractions that have factors, if you do not fully distribute that, that is actually usually my preference. If you distribute it and you do it right, I'm cool with that too. But it's often easier to leave it in its factored form, and it gives a nice visual check to make sure that you have reduced that fraction fully. So you could write this as 2 plus 2 radical 6, or you could leave the denominator the other way. Yes, sir?
Can you put the negative outside the fraction?
Yes, you could put that in the front as well. Leaving it in the numerator is considered mathematically appropriate. Bringing it out to the front is always considered mathematically appropriate. Yep. I want to do this bottom one because it gives us a great chance to look at a super, super, super important skill. So I want to rationalize the numerator. What do I multiply by if I want to rationalize it? Square root of a plus square root of b, top and bottom, so that I'm multiplying by 1. So I kind of want to jump to this point on the numerator. What would I have after I do my distribution and I cancel anything? What's my numerator going to look like?
0.
Not a 0. What do I get when I do radical a times radical a? Radical a squared, which would just be a. Plus or minus? When we multiply by a conjugate pair, it's always minus. Do I need to worry about the middle term here? Because it's conjugate pairs, the middle term is going to drop out. But I do need to multiply radical b times radical b, right? What is radical b times radical b? B. All right. On the denominator, I'm just going to write all of this down for right now. Whenever we've got fractions, before you tell me it's your final answer, what do you have to make sure about it? 2/4. Would that be an acceptable final answer? Why not? It's not fully simplified. It's not reduced. I have to check that here too. And I see something that's catching my attention, and I know this one is going to reduce. What do I see? Yes, sir.
The a and b in the one parentheses are to the power of 2, and then the other parentheses are squared.
I want to focus on this one right here. A squared minus b squared. What is that? It's not Pythagorean theorem. That's a squared plus b squared equals c squared. We were just talking about this a moment ago. I have something squared minus something else squared. From this, I can get conjugate pairs.
The difference of perfect squares.
Yes, this is a difference of perfect squares. Why is that catching my attention here, that it is a difference of perfect squares? What happens if I turn it into its factored form?
You could simplify, right?
Yes. So I'm going to rewrite that numerator, a minus b. Down in the denominator, I have c, and then tell me how my difference of perfect squares factors.
A plus b, a minus b.
Yep, a minus b, a plus b. Doesn't matter on the order. And then we've got this horrible factor that is square root of a plus square root of b. Do you guys see anything that will cancel? A minus b, top and bottom. So what would I have left in my numerator then? 1. Over that whole hot mess in the denominator, which I would not multiply out. I would leave it as c times a plus b times radical a plus radical b. I would count that as fully simplified. You've reduced it. I do not need to see the denominator multiplied out. So far, so good? All right. We've got 2 minutes till the bell. I've got a real quick one to throw at you. Like, seriously, about 30 seconds of your time. Square root of 121 simplifies how? 11. What about the cubed root of negative 8? Negative 8 to the 1/3. Does it simplify beyond that? Negative 2. All right. I still have some more examples of practice simplifying. I'm going to throw those up on the board as bell work next week so that we continue to get that practice, but so that we can start 1.3 on Monday. Please bring me any questions you guys have, or send me messages over the weekend in Canvas. I am more than happy to answer questions for you guys.